Welcome. We will get started in 2 minutes. If you're just joining, you are placed in silence mode, so feel free to get familiar with the tool. The Q&A session is where we expect the questions to be placed in for the speakers. We'll get started in about a minute. Just a couple of disclaimers. The session is being recorded and it will be available on demand. If you do not wish to participate in a recorded session, this is a good time to disconnect. So as a reminder, you're placed in silence mode. However, you can ask the question in the Q&A and they will be addressed in the appropriate moment of the presentation. Also, you can take your question to the social media channels, leverage the hashtag HiveMQ IIoT. All right, welcome everybody. I'm Lucian Fogoros. I'm the co-founder of IoT World, and today's session, Industrial Transformation Simplified with MQTT and Sparkplug, brought to you by IoT World and sponsored by HiveMQ. Good morning, good afternoon, and good day. Wanted to remind you that the questions should be placed in the Q&A section. You can also take them in the social channels, whether it's Twitter or LinkedIn, leveraging the hashtag HiveMQ_IIoT. Also, one lucky winner will be drawn from the active ones from the Q&A window, and will walk away with a 12 months access to the VIP community, and where you get exclusive CEO Insights series exposure, post-event networking opportunities, as well as resources to download it in one place. I'd like to introduce our moderator for today, Greg Orloff, who will be your host for this virtual conference. Greg, welcome. You're on mute, by the way.
Well, that's going to make it difficult, isn't it? Sorry about that. Thank you, Lucian, and good day, everyone. Now, before we dive into today's material, please allow me to give those of you who may be joining us for the first time a little background. IIoT World is a digital media publication that covers the economic and technological implications of the transformation that is taking place as industrial IoT proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the industrial Internet of Things. Analytica's 2020 report ranked IIoT World as the #1 global brand for industrial IoT. IIoT World was also recently ranked by Kcore Analytics as the #1 global influencer in a myriad of topics ranging from industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. And additionally, smart cities has been in the top 5 positions for the past couple of years as well. Our mission is to help companies create a culture of innovation and connect the smarts, industrial technology, manufacturing, sensors, and the CXO decision makers who seek these solutions. Now, today we have a very timely topic discussed by representatives from HiveMQ and CirrusLink. They're poised to provide a telling view into their perspectives on industrial transformation, MQTT and Sparkplug. Our agenda will discuss the issues of transforming the software infrastructure of a manufacturing process to make it more efficient, flexible, and interoperable. Dominic Obermeyer will present the common architecture pattern modern factories are using for connecting OT systems with enterprise IT systems to enable factory digital transformation. He'll highlight how MQTT can be used as a common protocol to connect OT and IT systems. Arlen Nipper will introduce the new Sparkplug specification that enables plug-and-play interoperability between IoT devices and IoT applications. So key topics covered are going to be how to integrate automation data with industrial messaging protocols, how to use MQTT in a mission-critical real-time environment, and how to deploy MQTT broker in the cloud or on-premises in connecting OT data to industrial and business applications. How Sparkplug can break down the data silos in your organization and provide single source of truth that enables new applications like machine learning and AI to take place. So I'd like to kick off our session today by introducing Dominic Obermeyer. Dominic is the CTO of HiveMQ. He's the lead architect of the HiveMQ enterprise, MQTT broker, which is used in the largest commercial IoT deployments in the world with multiple millions of connected devices. Dominic is a co-author of a book, The Technical Foundation of IoT, and is a technical expert in the IoT protocols and highly scalable cloud software. He's a member of the OASIS Technical Committee and standardized MQTT 3.1.1 and MQTT 5, and a frequent speaker on IoT and Java topics. Dominic, welcome, my friend. The floor is yours.
Hi, everybody. So thank you for the introduction, Greg. So yeah, today we're going to talk about modernizing manufacturing software infrastructure with MQTT. And so, thanks, Greg, again for the introduction. So as Greg mentioned, I am involved with the MQTT since a long time. I am a conference speaker and author on IoT connectivity, on messaging protocols, and I am generally also available for any conversations on Twitter. You can see my Twitter handle here on the left, also as well as on LinkedIn. So I'm very happy to connect in case you want to discuss industrial IoT architectures afterwards, or if you have any concrete questions, feel free to reach out to me directly. So the manufacturing industry is undergoing a change, and there are many buzzwords which are there, like Industry 4.0, which we see in Europe a lot, or industrial IoT in general. And there is a lot of things that are happening. So, for example, the rise of AI and machine learning is something people want to leverage, as well as cloud computing, cybersecurity, automation, and smart sensors. There are a lot of things happening here. And modernizing the infrastructure and modernizing the modern factory has a lot of unique business drivers. In general, it's really about improving the factory efficiency. It's about optimizing intra-plant logistics, more flexible manufacturing. So lot size one manufacturing is something that is very important for a lot of companies. And it's really about measuring and increasing the overall equipment efficiency by increase the availability of the equipment and avoiding non-planned standstill. It's also about analyzing and increase the quality and tuning the performance of the machines and the processes. If we take a look at the current situation, and I believe a lot of people who are in the manufacturing space know some of these things. So while everybody loves greenfield projects, usually you don't have greenfield projects in a lot of manufacturing settings. You have these brownfield settings where you have existing infrastructure, and also modernization initiatives are happening, but usually you have constraints and you cannot just start from scratch. This is very, very common. And only a few customers we've seen have the luxury of starting on a greenfield. Most of the deployments we've seen and most of the infrastructures we've seen really start with a brownfield. A huge problem is that a lot of data silos are there. So usually a lot of manufacturers historically didn't care so much about interoperability, especially if you have multiple vendors. It was usually pretty hard to move data around because there were data silos, and there are advantages by this, but modern architectures really don't need this kind of data silos, or they prohibit innovation in general. Some things we have seen a lot in our customer base, and this is something which I find is very interesting, is the IT and OT clash. So it sometimes feels like there are colliding worlds. And there's a reason for this, and I think this is very good, because IT is completely different to OT in many things, also culturally. But especially if we look at industrial IoT, really we have both worlds which need to come together, and it's very important to bridge the gap. But the current situation is that in many companies there is this IT and OT clash still happening. Also, manual interaction with OT software is something that is very common. So patching machines directly in a non-automated way is something that is happening a lot. While on the cloud side or on the IT side, there is cloud and infrastructure as a service, and there is a lot of automation happening here. Sometimes it's very hard to bring the same amount of automation back to the OT world. And this is usually a lot of manual interaction is involved. Also, some things are really difficult to scale, especially on the OT side. So many components aren't really designed to scale. So if you have an evolving architecture, sometimes this is really hard. And also downtime is something that needs to be avoided at all costs. And yeah, it's really important to have technology which allow you to have basically no downtime. Downtime always costs money. So the goal for modernization is very often more agile software delivery into factories. This also means a faster mean time to recovery. It's about enabling centralized command and control, enabling visualization of overall manufacturing process, and consistent and flexible software architecture. I believe many people here are familiar with the automation pyramid. So if you look at the usual deployment, on the one side we have the shop floor, on the other side we have the top floor. So depending on what layer on the pyramid you are, usually you care about different things, and also the time sensitivity differs a lot. So if you need to move data between the layers in the pyramid, then we talk about different kind of data. So usually there's some kind of ERP system involved. You usually have your manufacturing execution systems, then you have your SCADA systems. And then if you go to the lower layers, you usually have a lot of PLCs and then sensors and signals. And really the timing here is very different. On the one side, we're talking about milliseconds and microseconds here. And then if we go up, we sometimes aggregate data up to months and days. And so we have different levels of timings required. So, but the important thing here is a consistent and reliable bidirectional movement of data from the shop floor to the top floor, and sometimes even back, is required. And this between layers, but also if you're on the same layer. And this is something we want to discuss today, about different paradigms, about different architectures, and how this can be handled. And this is also where a technology called MQTT comes into play, which we will learn more about in a few minutes. So if we look at different areas in a factory, and of course this depends on the exact factory, but usually you have these different areas. We have the automation area, we have a manufacturing area, we have the factory area, and then nowadays you very often also have the component cloud in here. this is something we want to talk about. So as a pattern one, how to connect things intra-factory, but also connecting things inter-factory. And this is something that is very common, and we see a lot in our customer base, that a lot of companies who have multiple factories very often around the world want to centralize data, want to have in their enterprise data center, they want to have data analytics services, they want to have machine learning services, data lakes, in order to make sure they can do a lot of data analytics like predictive maintenance, which allows them to make sure and to observe what is happening here, and also bring back intelligence from all different factors, bring it together, and then make meaningful decisions based on this. So, and this is also something we want to talk about today, how companies today are connecting factories to the cloud and back with bidirectional data movement. And then there's something I find very interesting, which we see a lot in our customers, is the introduction of this so-called industrial IoT broker, which is very often used to connect different things in the factory and in the cloud and also the cloud, and to move data bidirectionally between all the different components, and which also makes sure you have this data channel where you can send and move data around from sensor to cloud. There are some technical challenges though. So reliable bidirectional connectivity across all levels of automation is a real technical challenge, especially bidirectional communication is something that is not always easy to do, especially if things are time sensitive. Another challenge is consistent data messaging across all areas. This is something that is also sometimes very challenging, and depending on the technology you're using, can be even impossible. So it's very important here. And this is also where MQTT will come into play here. Another thing which is extremely important, but is a huge challenge still, is security, especially if cloud communication is involved. So it is a real problem if you open an attack vector to your factory and to your applications inside the factory, if you're opening things through the internet. So again, security is very important and something you really need to consider from the beginning, because security is not a feature. It's really a design choice, but also we will see here how technologies like MQTT can help. And then this is a tough one, and this is something I believe many people have experienced, that there are lots of different hardware suppliers and a lot of protocols are out there and platforms. Things work differently, and there's really, what I said in the beginning, there's usually this brownfield environment where you have many vendors with many proprietary protocols or open protocols communicating with each other, but there is no common language between them. And this is something we will see now here with MQTT, but also we will see later on in the presentation. Arlen will show you Sparkplug, how we can also bridge the gap here. First of all, what is MQTT? So MQTT at its core is an Internet of Things messaging protocol. It was invented in 1999. Also, one of the inventors is here today, Arlen Nipper. So he will also show you a bit of history. And it's really designed for moving data around, and it has its origin actually with SCADA systems. So, but what is so interesting about MQTT, that the challenges back in 1999 are the same we now have with the Internet of Things. And this is why MQTT got so popular, because it really solves the data movement problem so nicely and so efficiently in such a modern way that it got the default protocol for all communication from device to cloud. And so yeah, this is really, really good. Then we have minimal overhead for client and bandwidth. And this is really due to the publish subscribe pattern. I will show this in a second what this means. But the publish subscribe pattern is something that is so different from the pull response pattern people usually use for connecting things, that you really have this very minimal overhead on the one side, but also the protocol is so efficiently designed that that the bandwidth you can save is immense. So we have customers who sometimes save up to 80% of bandwidth, which if you're using VSAT or if you're using a mobile connection really matters because this is still very expensive. And then MQTT is designed for reliable communication over unreliable channels. This is why MQTT is also very popular in the automotive space, especially in the connected car space, because as soon as you don't have a wired communication, you usually have an unreliable communication. And MQTT is a perfect fit for this. It has a lot of features, for example, 3 quality of service levels, which you can utilize to make sure and to indicate how important the data is, and the MQTT protocol makes sure that the data guarantees are held. So if you have, for example, a message which needs exactly once delivery, MQTT is able to do this. And MQTT even makes sure if you are disconnected as a device, that as soon as you reconnect, the message gets delivered with the data guarantees you want to have. So MQTT is very, very small in footprint. It's designed for very, very small devices. And it's actually a very modern protocol, but it's a very mature protocol because, again, it was invented in 1999. So it's not the new cool kid on the block. It's really something that is very mature and in the market for a very long time. And what we discovered is MQTT 5, which is the newest version, which was released in 2018. It has a lot of goodness in there, a lot of cool new features, which are very important from our point of view for industrial IoT. For example, we have things like share subscriptions, where you can split data streams between multiple consumers, which makes it possible for very large scale deployments where you have tens of thousands of data points per second you want to transfer, which is also very, very good here. So MQTT 5 is something, if this is supported by your vendors, which is really great, it's the newest version of the protocol. Usually nowadays, MQTT 3.1.1 is the protocol of choice for most vendors in the market, but it's worthwhile asking for MQTT 5, and because this really has a lot of things which even help you save bandwidth and make the protocol more efficient. So I quickly talked about the publish subscribe pattern. And this is something that is architecturally very elegant because it allows things like report by exception, which means you only need to send data if the data is fresh. So you don't need really to send a lot of old data around. But how does it work? So usually you have 3 components in an MQTT deployment. You have a producer, which is here on the left. Then you have one or multiple consumers for data streams. And then you have the data distribution component. It's the MQTT broker. And it works the following. It works similar to if you have a mobile phone. It works similar to the services in your mobile phone. For example, I have an iPhone and I get push notifications for a lot of things. So it's a similar mechanism. Because you have this one server which manages the session of all the components. So if you have a producer on the left, it will connect to the MQTT broker and will indicate that it has an active session. And then the producer of data can publish a MQTT message on a specific topic, on a messaging topic. And here on the right, we see subscribers which subscribe the broker and indicate that they are interested in a specific data stream, a specific topic. And as soon as a MQTT packet, published packet arrives on the broker indicates who is interested in this data, and then it will distribute the data to this one or multiple subscribers. So you have this one-to-many messaging built in. You can send one data packet, and then the broker can distribute to every participant who is interested in this data packet. And there are a lot of additional features which publish subscribe allows, which are very important for high-level protocols like Sparkplug, but we will see this later on in the discussion when Arlen presents Sparkplug. So it's really about decoupling the devices, decoupling the producers and the consumers, and you have this minimal overhead because the subscribers and the publishers are connected all the time, and only if a new data packet arrives, only the interested parties will receive the data. So this is very neat because you save bandwidth, and only if an event happens that is interesting for your applications, the data is delivered. Okay, how can we bring this principle back to our factory? So there are multiple ways here. Usually, and also nowadays, many components support MQTT out of the box. MQTT, as I say, is bidirectional. And by the way, in the graphic we just saw, we have a publisher and a subscriber. In reality, you usually have the publisher is also a subscriber. So you don't need two connections just because you want to publish and subscribe. You can reuse the same TCP connection, and then data can flow bidirectionally because every device, if it's allowed to, can publish messages and also receive messages. So MQTT is so lightweight that it is suited for constrained machinery. And there are, in fact, PLCs in the market which support MQTT out of the box, so they can publish and receive messages. So for example, Siemens has a way for producing MQTT messages and consuming them. Also, there are many MES systems which support MQTT out of the box. So you can, especially in a greenfield project, you can make sure that the components you're using speak MQTT, so you can speak MQTT down to the PLCs even. Usually, if you have a brownfield project, an additional, let's say, layer is required. So this is where Sparkplug comes into play. But again, we will see this afterwards. But you can absolutely use vanilla MQTT, and we have, in fact, customers who are doing this. Also, if you go to the higher level, higher in the stack, you can connect all the machines, all the applications with MQTT, and some of them need bridging to proprietary protocols, but in general, you can connect your factory and manufacturing areas over MQTT and make sure that you have this central data distributor, which allows you to have a very flexible architecture. Because what is so great about MQTT, you can add and remove any of the subscribers and the publishers at runtime. So you can really have an evolving architecture. You don't need to know everything from the start. You can add components as needed. And then we have level 4, which we call the cloud. And the cloud really is something that is connected over MQTT. MQTT is by far the most popular protocol to connect anything to the cloud. And so usually you connect your factory over MQTT to the cloud, as we've seen, to your enterprise data center. But you can, of course, also use one of the cloud services, for example, AWS IoT, Microsoft Azure. They also support MQTT out of the box, or at least a proprietary version of it, which you could use. And you can bridge it to any cloud. So very often, a lot of our customers are running highly available HiveMQ broker deployments in the cloud. So connecting interfactory. So let's go back to this picture, and how does MQTT play into this? So if we look at it from a higher level, if you have multiple factories which may or may not use MQTT, how do you connect them to your enterprise data center? How do you connect them to your data lake? How do you make use of the data produced in the factories, or some of the data? what is very common, and we have customers who are connecting up to very large numbers, so almost 100 factories worldwide, and they're doing this by MQTT. So what is actually happening here is they usually have also a broker running inside the factory, and then this broker, on the one side, it distributes data inside the factory, but also it is able to bridge the data to a centralized MQTT broker in the enterprise data center. And you can decide to send a subset of the data to the cloud, or actually all data. This is especially interesting if you wanna get a lot of the, let's say, sensor data, which you wanna reuse or use for your data analytics or for any kind of machine learning. So why do you use MQTT here? And one side is it's really designed for secure communication over the public internet. There are many reasons for this. On the one side, you don't have an attack surface on the factory level. Why? Because conceptually, the factory, the broker in the factory would open the connection to the cloud, but the cloud itself will never be able to connect to your factory. So this is really one way. So it creates a TCP, but only the factory is allowed to create a connection outside, so you don't have an additional attack surface on your factory. And then, of course, standard mechanisms like TLS are used, which allows you to have an encrypted communication channel from a factory to the cloud. You don't need VPNs or something else. You can really use cloud communication or the same technologies which are used for the public internet, which are used with other protocols like HTTP, because MQTT is so lightweight, and it decided to build upon all the standard components which are also used for the web. And then there are highly available MQTT brokers with security and scalability built in, like HiveMQ, which we will also see in a second. If we zoom into the picture, so what we see a lot is that the broker we have here are actually multiple brokers. And why is this? Because if you think about this, a broker is usually a single point of failure. If the central data distribution component, for example, breaks away, then nothing works anymore. And this is where enterprise MQTT brokers like HiveMQ enter the picture, because you can have multiple servers which form a highly available cluster, but are looking to the outside like a single broker. So you can have high availability with the simplicity of one virtual broker. And a lot of our customers nowadays decide to run on, if their own data center, on Kubernetes, on OpenShift. A lot of customers are running on bare metal servers or virtual machines. If you're going to the public cloud, you can use any of the virtual machines offerings or Kubernetes offerings. So the broker itself really is agnostic here, and data analytics services, data lakes, machine learning services, and so on are then connected over MQTT or over their proprietary protocols. So because enterprise brokers like HiveMQ are able to bridge to any protocol. So especially today, nowadays, a lot of people we speak to that don't want to have the burden of managing their own MQTT broker, but still want to enjoy a full MQTT implementation. They want to use MQTT 5. They want to use all the features. They don't want the restrictions they have with cloud platforms, which are severe most of the time. So they want to have a standard MQTT communication, but they don't want to manage the servers, but still want a very high SLA, but want to outsource this. So there are also managed MQTT services like HiveMQ Cloud, where the best experts in the world operating large-scale deployments run your MQTT deployment and still allow you to connect to your data lakes, to your services directly by, for example, bridging, using VPNs and so on. So you can really have a customized deployment here. So there are options if you don't want to run this themselves or you don't have the operations teams required for that. So from an implementation option perspective, so if you're in the HiveMQ stack, so usually you have your devices, which can be MQTT clients, which could be a sensor, for example, cars, but even whole factories. And then you have the platform, the HiveMQ platform, which consists of one or more MQTT brokers. And there's also a neat control center component, which allows you to get insight into every MQTT connection, into the data streams, and to learn everything what is happening here. And then we have this extension SDK, which we give access to our partners, but also to our customers. And then you can integrate virtually anything which has an API. So there are a lot of standard extensions available, for example, for some things like Apache Kafka or the Confluent platform, or also databases like Oracle, but you can also write your own proprietary extensions. Customers are doing this, especially if they have their own services written and which have a proprietary API, and our customers are using this for integrating virtually anything. And of course, you can run this on any cloud, from bare metal to containerized Kubernetes environments. You can run this everywhere. So HiveMQ provides really an MQTT broker with clustering for high availability. So you really, if you have a use case which is mission critical, then HiveMQ is something you should look into. There are many of the best brands in the world who are relying here on HiveMQ for delivering world-class services. We have deployments with customers who publish and receive tens of thousands of data points per second, which are multiple millions, billions and billions messages per month. And we have security integrations with virtually anything. So from your Active Directory to databases, anything is possible here. And we provide observability, which is required for anything mission critical. And of course, support for MQTT 5, which you want to use for new deployments. So our customers this is just a few of our customers. So we have billion-dollar companies in Germany like Heraeus, to brands like Audi, Daimler, ZF, Honeywell, Siemens, BMW. So we have a lot of customers who build new digital products, improve the customer experience, create more efficient operations and insights, and of course are connecting factories. We have a white paper available. You can find it under this link. We can also share this afterwards. So you can download the white paper, which will give you insight how to do this. And this was it from my side. And I'm now excited to give over to Arlen, who will talk to you about Sparkplug.
All right, thank you, Dominic. There's a lot of information there, but that was extremely enlightening. And judging from the questions that are coming in through the Q&A, I think it's going to be a great dialogue here in a couple of minutes. And once again, just as a reminder, if you can submit questions, please put them into the Q&A window and not the chat, because we won't be able to access them or address them online if you put them in the chat window. So thanks. Now, next, we've got a poll here, and I'm going to turn it over to Arlen shortly. Arlen is the president and CEO. He probably needs no introduction, but he brings over 42 years of experience to the SCADA industry, to Cirrus Link as president, excuse me. He's one of the earliest architects of pervasive computing and the Internet of Things, and co-invented MQTT, a published subscribed network protocol that has become the dominant messaging standard in IoT. He's worked with Amoco and Koch Oil and served as president and CTO of Arcom Control Systems and Eurotech Inc. His experience covers a broad range of technology, from the design and manufacturing of embedded systems and SCADA systems, infrastructure, and implementations. He holds a bachelor's degree in electrical and electronics engineers, a BSEE from Oklahoma State University. Arlen, I'll turn it over to you.
All right, thank you, Greg, very much. Thanks for that presentation, Dominic. That was great. I think everybody's got a quick poll up on the screen right now, but Greg, I'll go ahead and get started here, and we'll go through this. So again, thank you, everybody. I'm here to talk to you about digital transformation, Industry 4.0, IIoT, whatever name you want to give to it. We're 6 years into this journey of trying to get more efficient, more optimum with our factories, with our remote facilities, and how can we do that going forward? So again, my name's Arlen Nipper. I've been doing this for 42 years. I think that's probably enough said. I did have the fantastic opportunity to be one of the co-inventors of MQTT, and my claim to fame is I wrote the first tiny C MQTT client on an 8-bit Z80 microprocessor. So real quick, what does CirrusLink do? CirrusLink are in the business of providing MQTT-centric software for industrial automation, i.e. where did MQTT start and how can we leverage that? And we are strategic partners with Inductive Automation, which is an industrial application platform that we use in large part to leverage what we can do with MQTT going forward. Real quick, as Dominic said, we had the opportunity in 1998, 1999 to work with Phillips 66, that we had done a lot of work with them, and they had just gotten their brand new TCP/IP-based VSAT system, and they wanted it to work better. They wanted more information over their VSAT system, and they wanted it quicker. So we got to step back and say, well, for the 25 years that I had been in the industry, we had been using poll response protocols. And all of a sudden we had this new network transport. And remember, 1998, 1999, people still had RS-232 ports on their laptops, and were quite happy to use those RS-232 ports. So how could we make these systems better? So the design goals when Andy and I worked on MQTT was, number one, it had to be simple. We were relegated to 8-bit microprocessors with 64K of memory. Number two, it had to be efficient. We're talking about networks in the late 90s, early 2000s, where you were paying by the byte for bandwidth that you utilized. So to Dominic's point, we needed to take that information and be able to collapse that bandwidth 80, 90, 95% more efficient. Now, in 2000, 80, 90% efficiency meant cost savings in communications. But in 2020, that's 80 to 95% more information that we're currently leaving stranded in the factory floor that now we can get access to with the same bandwidth, if you think about it in that perspective. Number three is that a lot of people don't realize is that if we're in a control system, if we're on a factory floor, if we're on a pipeline, if we're monitoring a solar farm, if we're using water, wastewater, food and pharmaceutical, I've got to know the state of all of my MQTT clients, because no operational engineer is going to let me control a 5,000 horse pump if I don't know the state of that connectivity in real time. So that is the last one testament aspect of MQTT and why we designed it in. And you know, it's funny, Andy and I did the first version, 3.0 of MQTT. It took us about 6 months, but it took us almost a year to negotiate with IBM that when we got this out, it was going to be open. And I think that's why we're having this discussion today. Now, to Dominic's point, MQTT is also great because we left a lot of stuff out. And by that, what I mean is that MQTT is squarely built on top of TCP. So a lot of people read the MQTT spec and they go, Arlen, we can't use this. There's no security built in. And we go, well, wait a minute. We're leveraging the latest security of TCP/IP. If we wouldn't have done that, if we would have written our own security layer, again, we probably wouldn't be having this conversation today. And the other thing that we did is we did not require a specific payload or a topic namespace. And that has let MQTT blossom across the spectrum, from Facebook to all the cloud providers to opening and closing your Genie garage door with your cell phone. A very quick timeline of that. The fact that Andy and I invented it, it stayed very sequestered within IBM. Not a lot of people knew about it. 2011, Facebook Messenger had a blog post that said, hey, we're using MQTT for Facebook Messenger because it's so efficient. It doesn't drain the battery on a cell phone. Then we got into the standards bodies. We got the OASIS and IEEE standards. And now we're talking about taking MQTT back into one of its original design goals, if you will, is bring it back into industrial automation. So I think one of the other things is that because we did push things like Mosquito and Paho out into the Eclipse Software Foundation, now people could get their hands on it. We got it through the standards bodies. And to everyone's point here is that Node, I get a Raspberry Pi, I've got Node Red, I've got a tool now to leverage my knowledge of MQTT. So it's the democratization of knowledge now that everybody can get their hands on this technology, use it, play with it, learn it. Is MQTT here to stay? We've got to have that discussion. These are Eclipse surveys that basically show it's become the dominant messaging transport of, you know, the cloud industrial internet of things, applications and solutions. So how do we leverage that now that's here to stay? Now, what we're going to talk about here is that we are all talking about digital transformation. We look at all the tools that are available from the cloud providers, and we go, wow, this looks great. This must be simple. We'll just connect into our factory OT data and we'll be done. But in fact, people are figuring out now, 6 years down the road, that because of the issues that Dominic talked about with brownfield implementations and the siloing of data and all the proprietary protocols and the tribal knowledge in the factory, is that we're finding out it's difficult. So what we've got to do is step back and not look at this as a IT down to OT problem, but this is a OT problem where we need to provide an OT infrastructure that solves the OT problems first, that then is able to plug into cloud solutions pretty much seamlessly. And if you think about it, let's think about it in these terms. The Internet of People took off because they had two open available technologies. HTTP defined a transport, and HTML defined what was in that transport. And if we think about it, MQTT is that transport that we need for the industrial Internet of Things. And what I'm going to talk about is Sparkplug, defining that topic and payload of those MQTT messages so that we can have plug and play operability going forward. Now, here's the issue. This is a picture of a 1989 piece of brownfield equipment. It talks Modbus. And we have been doing automation for the last 42 years, at least that I've been in it, and we deal largely with register value pairs. I got Modbus register 40,027. It's got a value of 1,256. What does that mean? What do? Well, we double click on that and a human being edits it. He says, oh, well, this value actually is scaled 0 to 4095, but it represents 0 to 100 somethings, and those somethings are in PSI. And oh, this tag name, I'm going to call it suction pressure. And we hope we edited that right. And now, as we migrate to digital transformation, I may have 5, 10, 15 other applications that are subscribing to that same register value pair. And they don't have any context. So every time we change anything in the field, we're constantly editing and changing our process variable database, if you will. So that brings to point is that 4 years ago, we kind of looked out at the landscape. We saw Microsoft and Amazon and Google Cloud Platform and IBM Watson IoT and Siemens and Opto22 and all of these device manufacturers. Everybody were using MQTT, but everybody were using it differently. So we took lessons learned of the 20 years that we've been applying MQTT to industrial automation, and we came out with a spec called Sparkplug. And it doesn't change MQTT. It works with MQTT 3.1.1. It works with MQTT 5.0. It just defines a topic namespace and a payload representation that makes sense in an industrial environment. So very quickly, I'll step through that. The first thing by having a standard topic namespace is I've got plug and play auto discovery. Given the fact that I know there's a group, a node, and a device, I know where this message came from. A birth tells me I just had a new device come online. A DData command means that I've got a piece of report by exception information. Now I can update my process variables. And again, I've got the notion of a death already built into MQTT, and I've got the notion of a birth, and now I manage the state of my devices. Now, the next thing that we're going to realize is that, yes, although we can define a process variable in MQTT, we need to start looking at the ability to have models and assets published as a single source of truth from the edge, because that is where cloud technology is leading us to. Not just tens of millions of tags in a data lake, but a model that tells me I've got this machine model, I've got 10 of those are my assets, and those assets have measurements. Now, the next thing that we did is that, again, you can define your own payload within MQTT. And I always say, you know, the beautiful thing about MQTT is you can publish anything you want on any topic. The problem is that you can publish anything you want on any topic. So what we did is we defined an efficient binary encoding of a process variable object, a measurement object. We've got a name, a value, a timestamp, a date, time range, quality, custom properties, so that that measurement, if it goes up into the cloud and I want to find it a year from now, I've got context for that process variable. And then the last thing, with proper state management, that means we can do report by exception, we can do bidirectional command and control, and in a lot of factories that we're automating, that means we can do store and forward. So if our factory network, if our remote cellular network gets disrupted, we take those MQTT messages, we put those in a queue. When our MQTT session comes back, we can publish that historical information because we have a timestamp doing gap fills for all of that OEE, MES performance information where we don't want to have any gaps in our data stream. Now, if we look at that and we had OEM devices, edge of network gateways, native devices with all of these different protocols, with OPC UA, with native proprietary protocols, if we could model those process variables and those models, that means we could have a single Sparkplug message published, boom, that defines a model, that defines an asset instantiated from that model, and defines the measurements within that asset as well. Now, what I'm going to do is step through a very quick commercial implementation of this that's out there in the world today, and that is using a product like Ignition, which is an industrial application platform that lets me go and build models in that platform called user data types. And those user data types can be instantiated to create assets, and then those assets have measurements. And now I've got a single source of truth for my machine on the factory floor all the way up into my operational system. Now, let's take that to the next step. We have Amazon, Microsoft, IBM are starting to come out with services now that lets us build models in the cloud. So one of those example that we work with Amazon has a new service called SiteWise. And in SiteWise, you can build a model. Then you instantiate that model that creates an asset, and then that asset has measurements. Now, the advantage here is that I can then go into a factory and start building my models literally on the factory floor, where the engineers live, where all the technicians live, that know about all of the idiosyncrasies of my factory. Oh, this is a particular brand of PLC, but somebody else wrote their own ladder logic, so we're going to build a model for that. We're going to build a model for all of the native devices that are on the factory floor, and now we have those in our operational system. Well, now just think about if we could connect into the MQTT broker that's native on AWS called AWS IoT Core, or to HiveMQ broker, or to a Cirrus Link Chariot broker, using a SiteWise bridge service that would let us feed information directly and build models in AWS SiteWise. So imagine me being able to go to a factory and in just a couple of minutes, all I had to do to get all of my model, assets, tag information with its engineering units, with its attributes, modeled in Amazon Cloud Services is simply the configuration of an MQTT connection, using MQTT Sparkplug to publish my birth messages that contain my model, that contain my asset, and then from there on out, using data messages to publish report by exception and have all of that information end up in the time series database on SiteWise. Now, I've just shown you one commercial instance of this. And one of the reasons I'm here is to talk about why we did this. So one of the popular aspects of MQTT is we started a project in the Eclipse Foundation called PAHO. And I would venture to say that 99% of every MQTT client in the world today probably started by some of the assets that are in the Eclipse Foundation in the PAHO project. Now, we've done the same thing with Sparkplug. So we've started a Sparkplug working group, and we've started the Eclipse Tahoe project, which provides access to the current Sparkplug specification, which is not owned by CirrusLink, it is owned by the Eclipse Software Foundation. So with the information here, my call to action to the audience on this call today is go check out the Sparkplug working group and Tahoe and learn about what we're trying to do in standardizing MQTT so that it becomes the Internet of People's HTML, if you will, for MQTT. So with that, Greg, I'll hand it back over to you.
Great. Well, thank you, Arlen. That was a lot of information as well. Fantastic. I think my biggest takeaway from that is get engaged, everybody. I mean, you've got two living legends that are the foundational principles on MQTT and a whole bunch of other things. Check out the working group and check out Tahoe. So now it's time to transition to our Q&A portion of today's session. And we're going to entertain the proliferation of comments and questions that are coming in under the Q&A window. Once again, if you can, put those into the Q&A just so we make sure that we get all of them. And in the event that we can't hit every one of the questions today, we will be carrying over and migrating the conversation to Twitter. So we'll be able to follow up with you individually using the hashtag MQ or HiveMQ _ IIoT. Once again, that's hashtag HiveMQ _ IIoT. And there will be a recording made available at the end of the session today. So rest assured, the folks, you can go back and listen and digest some of this information. I think what we've popped up now is some of the results from the poll that we had earlier. So it looks like, what best describes your company's current state of the union and experience with MQTT? The largest are in the learning phase, it looks like, Arlen, Dominic, and we've got some that are using it in IT and OT. That's a good thing to see as well. And smattering across the other things. It looks like you've got a lot of people that are interested in learning about it, and you've got a slightly smaller group that are already engaged and moving forward and pressing through on both IT and OT. So thanks everyone for joining in that and participating in the Q&A portion in our questionnaires. So maybe if we jump into some of these questions that are coming in, let me look here. I'm going to dive right into the Q&A because there's a lot of them in here. Maybe more of a fundamental one. I think this is something you may want to touch on. This is from Ashwani. He says, is MQTT and LoRaWAN the same thing?
No, we're interfacing with LoRaWAN. LoRaWAN is a it's a very constrained wireless protocol, if you will, that is using very inexpensive sensors, typically battery powered. We have a lot of our oil and gas customers using LoRaWAN. We go into a gateway where we take the LoRaWAN information and publish that in MQTT Sparkplug.
Yeah. Yeah, absolutely. Also to add here with LoRaWAN, So especially things like MQTT for sensor networks, which is an upcoming standard, which is not yet released. So I would suggest using this. This might be, if you really want to use MQTT over LoRaWAN, this might be great to use things like MQTT for sensor networks, but which is based on UDP. But I certainly wouldn't go this route right now. So as Aaron said, so it's absolutely not the same.
Response. So the boss has a question. Says we have multiple publishers, or more than one of them publishes at the same time. Does that affect the quality of the data set?
So can you just repeat the question, because it seems like
if we have multiple publishers and more than one of them publishes at the same time, publishing simultaneously, does that affect the quality of the data?
So what? Yeah. Greg, your audio is kind of messed up, but Dominic, I think it was the question that came in, is that if I have multiple MQTT clients and they all publish information at the same time, does that affect my data quality? I will just say one thing, is that MQTT is very, very fast insofar as on the wire. But that's one of the reasons that we did add a millisecond timestamp to Sparkplug, so that even if you had tens of thousands of sensors all publishing at the same time, if they get skewed at all, you're still going to have the timestamp that was on the original measurement. So Dominic, I'll hand it over to you.
Yeah, really, absolutely. And so on the one side, it was really designed to be fast. And also what is the beauty here is the TCP connection, which is bidirectional. Just from a few anecdotes. So we have customers who have very high data frequency of sending and receiving data. So we're literally talking about thousands of messages per second sent and or received, which is usually sufficient for most deployments I'm aware of. So no, there's no problem here. And as Aaron said, protocols like Sparkplug also have this additional field, which gets you covered even in case you see any congestion on the network side. But usually this is not something you will see a lot in real deployments, that you have problems here.
You guys hear me okay now, or am I still coming through broken?
So Greg, I think your audio, there's a problem with your audio.
Yeah, my audio. I'll call in. Do you want to address the next question then?
Well, I'll pick one out here real quick because it always comes up. It says OPC UA, MQTT and OPC UA. I think they're complementary. I don't want to say that OPC UA and MQTT are conflicting in any way, but typically, we see OPC UA as that machine to OT connectivity, but it's definitely more complex. And if we look at the simplicity of MQTT and sensors coming out with smaller CPUs, then the implementation of MQTT is much, much easier than the implementation of OPC UA. Now, with the modeling capabilities of Sparkplug now, in being able to build models and assets, however you want to build those, I think you have to look at your overall infrastructure design, and I think it will always be a combination of MQTT and OPC UA.
And also what we see a lot currently is that OPC UA is, as Aaron said, it's here to stay. But especially if you're more on the greenfield side of projects, what we see is that people are amazed that how easy and fast it is to get started with MQTT and Sparkplug. We're literally talking about connecting things in days instead of weeks or months, because usually from anecdotes from our customers, it's really not that easy to get the OPC UA infrastructure up and running. With Sparkplug, it's extremely easy. So this is a major driver towards Sparkplug for use cases where you could use both OPC UA or Sparkplug and MQTT. So I think this is really great, because this gives companies a very easy way to get started, use Sparkplug. And actually, I think the principles like repro by exception really make a lot of sense for specific use cases. So I think it's really great to have both options. But of course, a lot of people using Sparkplug want to use it for more things because it's just so easy to get started and it just works beautifully.
Actually, Greg, this is Ian. Maybe I can help with reading the questions if you're still having audio problems. So if the factory is running HiveMQ MQTT broker to broker messages in the factory, how is the broker publishing messages to the enterprise broker? Is HiveMQ both a server and a client?
Yeah. So in this case, yes, the broker acts also as a client. So there is a mechanism called bridging, which allows the broker to send parts of the topic structure of the data stream to the cloud, or even subscribes to data streams from the cloud. So you have this bidirectional data movement. So in this case, we have the so-called bridge extension, which can be used for exactly this. And you can consume and produce data here. And so the broker acts basically as a client for the cloud.
Okay, another kind of follow-up on the OPC UA discussion. Where's the key gap in MQTT security standards compared to OPC UA? Does it support PKI security?
Well, from my standpoint, and Dominic, I'll let you jump in, but right now, I mean, that's kind of the beauty of MQTT is that typically the IT department of any company sets their security standards. So, we have customers that use everything from SSH tunnels to VPNs to TLS certificates. So it's pretty much you get to pick your security model and then on your TCP/IP network, and then whatever you pick, MQTT is going to run on top of that.
Okay. So how do you see MQTT used for videos and imaging information in the industry?
Well, MQTT is not a streaming protocol. We'll leave it at that. But we have a lot of customers at remote locations that are taking snapshots and very short videos and publishing those via MQTT. So we are literally seeing that today.
Okay.
Yeah. I think I'm back. Can you guys hear me now?
You are, Greg, for sure. You can take back over if you want.
I appreciate it, Ian. It's the inevitable technical difficulties sooner or later worm their way in. All right, let's see what else. We've got some great questions in here. Apart from the typical use case of predictive maintenance and IIoT, are there any other typical use cases that are more process oriented? They're looking at specifically the medical device manufacturing environment. Have you guys seen anything in different arenas?
Well, from an operational standpoint, remember that's kind of why I included the history of MQTT is that there are major pipeline companies in all over the world that are both monitoring as well as controlling their pipeline using MQTT. So as Dominic pointed out, it is bidirectional. So if my Wago PLC or my Siemens PLC supports MQTT, I'm probably going to be able to send it commands as well as getting information from it. So that means I can send a set point, I can send a motor on off, I can send any sort of a command that I need to change something that might be in the in my OT environment. But again, having that integrate seamlessly into my IT and digital transformation environment as well.
Yeah. So also to add, so there are so many use cases actually which are done with MQTT we have seen over the years. We have some case studies also online on our website on HiveMQ.com. For example, we have a case study with Daimler, and this is not medical, of course, but this is automotive. But they use MQTT for improving the quality and making sure the quality of the cars they produce. So in this case study, they talk about how to use MQTT to get data out from the cars, from all the control units in there, and then ship it to a quality control application. And they use also the bidirectional data movement of MQTT for this. So there are many more use cases here. So you can check some out on HiveMQ.com, where we have case studies with some large brands where they talk about how they use MQTT for different things.
Arnold's got a question, or actually a comment. He's saying he loves Spark. The Sparkplug enables MQTT to model data. What he doesn't understand yet is the modeling done on the integration, or are they defined by equipment manufacturers out of the box?
It's typically done. I mean, I go back to my notion. It's all about tools on platforms versus coding on operating systems. And I think a lot of the project inhibitors on a huge number of customers that we had as they put data into the data lake is that now they had to have another crew of IT guys pull the tags out of the data lake and put it back into context. So the tools that we're looking at with Sparkplug are being able to define the model using tools, using drag and drop, all the way at the OEM equipment. So not all customers want to use those models the same way. They're going to want to be flexible. So we've got both manufacturers sending out of the box, but most of them let you change that to your use case. And again, people can see my basement layer here. And this is all equipment that supports MQTT Sparkplug that we work with, OEMs that we are working with today.
Joy's got a question. It says, for argument's sake, can the industry replace OPC-UA with MQTT? And if so, what are the significant challenges they would need to take into account?
Well, I don't want to get in. I just don't want to get into OPC-UA versus MQTT. Again, to Dominic's point, a lot of times I go back to keep it simple, stupid. And OPC-UA can become very complex, especially when you're trying to do it over a wide area and you've got all these ports open and you've got a lot heavier communications, if you will. Now, so I think there's always going to be that give and take. Now, for OPC-UA, if I was doing, a 4020 milliamp closed loop control PID controller, then yeah, that's definitely been designed to be that closed loop command and control. But once you start getting away from that, you're getting into intra-factory and then intra-factory to cloud, MQTT, and again, having that one-to-many capability of MQTT is huge. It's that decoupling of devices. I should not connect a device to an application. I should connect a device to infrastructure, connect applications to infrastructure, and then pick the best in class.
So we've got another question that came in. It says, why is there no need for a VPN?
So I think this question was asked when I talk about connecting factories to the cloud. Because it really doesn't. So it could make sense in some cases, but if you're just using a VPN because you want to have the encrypted communication, this is really not something you require. If you're using VPN more because you want to connect the networks, this might make sense. But just for the data transfer, the bidirectional, it's really not required. The reason is because, as Aaron pointed out, MQTT is so simple because the beauty of it is it reuses the technologies which the internet is built upon. So it's used. So TLS or SSL is used, which means the same networking stack or the same encryption methods can be used, which are also used for HTTP, which is used for the web, which is huge because everybody has this. It's super cheap, it's commodity. And then you just do your TLS handshake and then you have an encrypted bidirectional communication. So you can, of course, use things like client certificates, which to add additional layers of security. But in general, you really don't need this. Just use an encrypted TLS communication channel, which is very easy to do. So you don't need any additional equipment. It's actually that simple to configure. And so you really don't need this if you're just looking for the encrypted communication channel from factory to cloud. And what is so great about this is MQTT the client always initiates the connection to the cloud. So the cloud is never able to connect to the factory or open a connection by itself. So also from a firewall perspective, this is, I mean, you don't have an attack vector because you have the MQTT client, which acts here on a broker side from the factory, which connects to the cloud. And then if this is established, you have this bi-directional communication channel, which is open. And this is really very simple. And from a security perspective, you don't get any better than no attack vector. So this is really great.
Right. The point there is that with an MQTT client in the factory, there can be 0 ports open at the factory, no ports open. It's an outbound connection. And if you look at it, why did IBM, Google, Microsoft, Amazon, SAP all choose MQTT as their IoT ingest? It's because they could offer that level of security.
Maybe if we take back a level for a second. So Dominic, I mean, what's the best way for an organization to get started with MQTT and Sparkplug?
So there are many ways. So for people who are learning about MQTT, on the one side, there's the MQTT specification to read. It's really a very lightweight, especially compared to other specifications, because it's really just a few pages, like 70 pages or so. If you want a more digestible way, so on HiveMQ.com, we have a series called MQTT Essentials, which is available in video format, which is approximately 1 hour, where you get all the nitty-gritties, every detail, all features of MQTT explained in a very concise way, in a very digestible way. We also have an ebook available, which speaks about MQTT 3, MQTT 5, everything you need to know. And with this, you're equipped to get started with MQTT. For Sparkplug, there is the Sparkplug working group. So Aaron showed this to learn more about this. There's also a great collection of articles. So there's also a newsfeed here. So articles are collected about Sparkplug. And the Sparkplug specification is also, you will be surprised how simple Sparkplug actually is from an understanding point of view. And there are really just a few pages. So this is compared to any specification you see in the industrial automation field. It's really very, very simple. But also here we're currently running a Sparkplug Essential series on HiveMQ.com, which also makes it even more digestible, and which also gives a bit of context here, which we run this currently. So we release that blog posts very soon, so you can subscribe to our newsletter on HiveMQ.com to learn more about this. But in general, the Sparkplug working group, as Arlen pointed out, is really a very good way to start.
I think you touched on this question, but I'm going to throw it out there anyway. Ivo, I hope I'm pronouncing your name right. Ivo, is MQTT a solution for low power devices? You know, let's say something that makes a sample every hour or communicates once a day.
This is a battery powered 4 to 20 milliamp sensor. It has 2 analog inputs, 2 digital inputs, a relay output. It's got a battery, it lasts 5 years, and it does MQTT Sparkplug.
All right, there you go, Ivo. Coming at you live.
Okay.
No, that's fantastic. You know, maybe touch a little bit on the adoption of this. You know, what's the adoption rate of MQTT right now, and Sparkplug? Are OEMs starting to include this in their products?
Yes, like I said, the whole wall behind me is OEM equipment. I'm not here to validate him, but I've got that sensor with SignalFire. We've got Opto22. We've got Wago. We've got Moxa. We've got Advantech. We've got OnLogic. And there's more and more coming out. The number of people that have announced it that I didn't even know about. I mean, we have products coming out with, and they'll say on the tagline, MQTT Sparkplug enabled. Now, again, we realize brownfield means we still have to have edge of network devices out there that are converting brownfield protocols to MQTT Sparkplug. But in a lot of cases, we already have to have edge compute out there anyway, whether it's from a security standpoint, a cellular network standpoint. So we're finding things like Cisco routers that have Docker containers. Well, I've got a Cisco router, I can run my edge software on it, I've got a Docker container on it, I'm ready to go.
Got it. No, so Arno has another question, and once again, I think this is something that you guys touched on as well, but is bandwidth actually a bottleneck in vertical industrial communications? If you've got a network that's running Ethernet connected assets, does payload size really matter that much?
My adage there is you can always scale up, but it's really hard to scale down. So we still have customers running on 300 baud dial-up slip connections. Now, again, common denominator is we have VSAT, we have radio, we have cellular. Yes, we have gigabit fiber. But if I have a solution that can scale all the way down to that minimal bandwidth, then if I have excessive bandwidth, that's great. No, not a problem. But if I can't take that and scale it down, and let's say I'm at a factory and I have a water tank back in the back that's on a cellular network, I still want that to be efficient.
Yeah. And also to add here is something that a lot of people experiences with added bandwidth. If you just basically put a lot of noise here, things you don't need. This also on the other side, you need compute in the end, because even if you just don't do anything with it, in the end, it's just so resource intensive if you do things you shouldn't do. And so, yeah, also to add to Aaron's point, I think it's very, very important to have a solution which is flexible to add things, which Sparkplug and MQTT allows you to do in a very easy way. But also, really, for everything you do which you shouldn't do, you are also wasting compute. And this is something that can be problematic at some point of time, especially if you have a very large-scale deployment.
All right, we've got time for maybe one or two more questions here, because I know I want to get onto the wheel of opportunity, if you will. Looking at this right here says, okay. I think we've addressed most of these then. All right, Lucian, if you're ready, I'm going to turn it back over to you for a second, and we can get queued up for our wheel of names, so to speak. And what we're going to do is, there's nothing you have to do on your end, everybody. Basically, we're going to take all the folks that have been active in the chat and the Q&A session today, and we're going to enter you into a drawing. And we're going to award the winner from the Wheel of Names with a one-year subscription to our VIP IIoT World behind-the-scenes private area. So,
thank you, Greg. So just real quick, I grabbed the names of roughly about 48. Some of them were in anonymous mode, but here we go. I'm going to type them in. Hopefully you see the screen. Somehow it's blocked me, so that's okay. I'll switch to another one. Wheel of Name here. That's very odd. It doesn't allow me to type. It's very weird. I'm going to stop sharing real quick and then cut and paste them there. I apologize for the technical difficulties. Greg, if you find other questions, go ahead and do that, because
sure.
This was just
all right. Well, Lucian's well, he's working our wheel. Take a look at the bearings and see how we're doing there. Maybe we'll jump back in for one more question. Let's see. So the MQTT specification doesn't define security. So how can someone possibly use it in their infrastructure? Arlen, you want to take a poke back at that comment?
Well, I think we've hit on that several times. MQTT exists because of TCP. So you're right, MQTT does not address security. TCP/IP does. And so whatever your company is using to secure its TCP/IP networks is the same technology that you use to secure your MQTT communications.
Yeah. And also, in addition, many companies also, if they want even more in addition to what MQTT provides on the transport layer, there's also on the application, there are a lot of things you can do. So for example, authentication, authorization mechanisms can be used also on the application level. So for example, MQTT has support for username and password fields, which can also be used for carrying security tokens. So you can use this basically with anything you want. So for example, we have customers using their Active Directory or LDAP server with the MQTT broker, who are using their databases of equipment to make sure only equipment is allowed, the right equipment is allowed to communicate. And you can even restrict with many MQTT brokers where data can be published and subscribed to, and who is allowed to do this.
Right.
So there's really a lot of options. And also, if you're curious about this, we have written a lot of options here also on our website. We have our developers tag here, link menu, where you can find also security guidances. We have a 10-part series on HiveMQ.com, where you can also learn more about all the layers. And
yes, I think to Dominic's point, we posted, I think Ian's got those posted in the chat window. If you want to take a look at those links to the different websites that we're talking about here. I know they're coming across fast and furious, so no need to scribble them down. You can grab them right out of there. So I think, Lucian, it looks like we may have the wheel back up and running.
Correct. So I typed in all the names that were in the Q&A. Thank you, Greg. And I'm just going to hit spin, and the winner is going to walk away with a 1-year subscription to the VIP community. Again, you can find everything in one place. And there is Ashwani, my John. So I'm going to take that via email. So Greg, I'm going to turn it back over to you.
Okay. Well, thank you. Congratulations, Ashwani. And thank you to everyone for joining us for today's session. Please make it a point to visit our events page for up and coming educational webcasts brought to you by IIoT World. Next week on November 19th, we have an event titled De-risking Software Safety Certification, How to Lead Your Organization to Certification Success. So make sure you register for that one. It's going to be a very insightful session. Special thanks to our sponsor, HiveMQ, for this educational session, and to our speakers, Dominic and Arlen. Always a pleasure. It's outstanding to work with both you gentlemen. If you folks have a suggestion for a topic or otherwise, we always welcome feedback, so please drop us a message and let us know. If you like what you heard today, we'd invite you to subscribe to our newsletters, our YouTube channel, and also follow us on Twitter at IIoT_world. This concludes our program for today. Thank you for joining us.
Bye, everybody.
thank you. Bye.